Hope you are fine at home. I hope you are doing your works also. So last time we did compounds, since the video was sent for class 7 and 8, so I said you to do through that video only. Now today I will tell you what is the difference between element and compound. The difference between element and compound. Element is made up of only one kind of atoms. Element is made up of only one kind of atoms. Example, hydrogen element H2. So how do we write hydrogen element H2? Is made up of only hydrogen atoms, that is H. So hydrogen element H2, because it is diatomic molecule, it is diatomic molecule, so we write H2 is made up of only hydrogen atoms. So in hydrogen element there is hydrogen atoms only, no other elements. But here in this case of compound, the compound is made up of two or more compounds of kinds of atoms. The compound is made of two or more kind of atoms. For example, water H2O. You can see the difference here. In this hydrogen element there is H2, H and H. But here in water there is hydrogen as well as oxygen. Hydrogen as well as oxygen. So hydrogen is also there and oxygen is also there. That means it has two or more kind of atoms. It has two or more kind of atoms. Each contains atoms. In case of water, it contains atoms of hydrogen and oxygen. It contains atoms of hydrogen and oxygen. So what is the first difference? Elements are made of same kind of atoms. Compounds are made of different kind of atoms. Elements have their own set of properties. Example, the element is self-combustible, hydrogen is self-combustible, and oxygen supports combustion. So what is there? Elements have their own set of properties. Own set of properties. That is, hydrogen is combustible and oxygen supports in combustion. Let's see here. The properties of compounds differ from their components. The properties of compound differ from their components. For example, water. Water contains hydrogen and oxygen. But here in water, when we talk of water, water is made up of hydrogen and oxygen. We know that it is made of hydrogen and oxygen. But the thing is that hydrogen is combustible and oxygen supports combustion, but you know that water neither is combustible nor supports combustion. That means here elements have lost their properties. That means properties of compounds differ from their components. Here properties of element is fixed. They have their own set of properties. Here they have different. The components will lose their property and they will show property of compound as a whole. Number 3, elements cannot be broken down into two or more simpler substances by physical or chemical means. Elements cannot be broken down into two or more simpler substances by physical or chemical means. If you break gold into many pieces, then you cannot get the simpler substances than gold atom, than gold element. So it is the simplest substance. Element is the simplest substance. And here the compounds can be broken down into two or more simpler substances by chemical means. But compounds can be broken down into simpler substance by chemical means. For example, water can be broken down into hydrogen and oxygen by the process called electrolysis. But there is no physical or chemical means which can break element. That means in short, if I have to say, elements cannot be broken into simpler substance by any means, but compound can be broken into simpler substance by chemical means. So these are the differences. So let me repeat it again. Elements are made of same kind of atoms, made of only one kind of atoms. Compounds are made of different kind of atoms combined chemically in a fixed proportion by mass. Here elements have their own set of properties, but here compounds, properties of compounds differ from their components. Elements cannot be broken down into simpler substance by any means. Compounds can be broken down into simpler substance by chemical means. Okay? Then let's see compound table 3.3 OPU. You have to make it in copy. If you do not have a word copy at home, then you can do all these things in your note copy. So list of some compounds. Compound here molecular formula, and this is very much important. Learn this molecular formula. This is very important. So water, what is the formula? H2O. Sodium chloride, NaCl. Calcium oxide, CaO. Sodium sulfate, Na2SO4. So Na2SO4, why? Because valency of sodium is 1 and valency of sulfate is 2. So crisscross, you will be getting Na2SO4. Then sodium hydrogen carbonate, NaHCO3. Iron sulfide, FeS. Sodium hydroxide, NaOH. Ammonium hydroxide, NH4OH. Ammonium chloride, NH4Cl. Sodium carbonate, Na2CO3. Then hydrochloric acid, HCl. Sulfuric acid, H2SO4. Nitric acid, HNO3. Magnesium oxide, MgO. These you have to learn. Okay? So this you will learn. Then continue. List of some hydrated compounds. Hydrated compounds. So what do you mean by hydrated compounds? Compounds containing water molecules. So what are hydrated compounds? Compounds containing water molecules. Compounds containing water molecule in the molecule. In this molecule, see here. Sodium carbonate. Sodium carbonate, whose common name is washing soda. This we use for washing clothes. Washing soda we use for washing clothes. That means it is there in detergent powder, and it is there in detergent powder and in the form of cake. That is soap. So sodium carbonate, washing soda. What is the molecular formula of sodium carbonate? Na2CO3 dot 10H2O. That means in washing soda, one molecule of washing soda contains 10 molecules of water. That's why this is called hydrated compound. Then copper sulfate. Common name of copper sulfate is blue vitriol. Its molecular formula is CuSO4 dot 5H2O. That means copper sulfate contains 5 molecules of water in 1 molecule of copper sulfate. Then cupric nitrate. CuNO3 whole twice dot 6H2O. That means cupric nitrate contains 6 molecules of water. Then magnesium sulfate, whose common name is Epsom salt. So what is the common name for magnesium sulfate? Epsom salt. MgSO4 dot 7H2O. That means Epsom salt or magnesium sulfate contains 7 molecules of water. Plaster of Paris, gypsum salt. I think you are familiar with this plaster of Paris. Whenever there is a fracture, bone fracture, then doctor uses plaster. Generally, we say plaster only, but it is plaster of Paris. And common name for this plaster of Paris is gypsum salt. So, what are the elements present in that gypsum salt? Plaster of Paris is calcium, sulfur, oxygen, and water molecule. calcium sulfate dot 2H2O dihydrate, calcium sulfate dihydrate, magnesium sulfate heptahydrate, hepta means 7, cupric nitrate hexahydrate, copper sulfate, its chemical name I am saying, chemical name for this is sodium carbonate decahydrate, copper sulfate pentahydrate, cupric nitrate hexahydrate, magnesium sulfate heptahydrate, calcium sulfate dihydrate. Then zinc sulfate is called white vitriol. See here, common vitriol. Vitriol means salt of sulfate. The salt which has sulfate in it are called vitriol. Blue vitriol because copper sulfate is blue in color. White vitriol because zinc sulfate is white in color. So white vitriol. Formula ZnSO4.7H2O, zinc sulfate heptahydrate. Okay. Then continue. Ferrous sulfate, green vitriol. Ferrous sulfate, green vitriol because ferrous sulfate is green in color. And formula FeSO4.7H2O. Iron sulfate, ferrous sulfate heptahydrate, barium chloride BaCl2.2H2O. Then aluminium sulfate Al2SO4 thrice 18H2O. So it has 18 molecules of water in one molecule of aluminium sulfate. Then this is potassium aluminium sulfate. Potassium aluminium sulfate. This is also called Fitcari or alum. We are very much familiar with it. Fitcari or alum. So common alum. So what is the common name for this? Fitcari or alum. And the formula for this is K2SO4 dot Al2SO4 thrice dot 24H2O. So this contains 24 molecules of water in one molecule of alum. That means alum or Fitcari, you are very much familiar with it. One molecule of this contains 24 molecules of water. So all these are crystals. Whatever salts, whatever hydrated compounds I say, these hydrated compounds are all crystals. Now you must be thinking, what is crystal? Crystals are solid substances having fixed geometrical patterns. They have fixed shape. They have fixed shapes. So note in the above table 3.4, the names of hydrated compounds along with their commercial names are given. So these are their commercial names or common names. The molecules with their formula, the water molecules with their formula is called water of crystallization. So what we call these water molecules? Water of crystallization. What we call these water molecules? Water of crystallization. Then water hydrated compounds containing water of crystallization. Compounds containing water of crystallization in their molecule is called hydrated compound. Okay, so the water molecules with their formula is called water of crystallization. So how many water molecules are present in alum? 24 water molecules are present in alum. Okay. So you will learn all this formula. There is no other option. You have to learn. You have to by heart this formula. Okay. Now mixture will be. We have finished so far. We have finished elements and compounds. Then mixture. So generally, in our daily life, we use many things. We not only use pure substances. Maximum 70, 80, 90% of the matter, of the substances we use in our daily life are all mixtures. For example, tea is a mixture. Milk is a mixture. Rice is a mixture. So whatever you see, maximum we use is a mixture. Hardly we use some pure substances. If you see water that we drink in our home is also a mixture. It is a potable water. Potable water is a mixture. Tap water is a mixture. It contains salt, then gases dissolved in it. So it is also a mixture. So maximum things we use in our daily life is mixture. That's why to learn mixture is very important. To learn mixture, to know about mixture is very important. Mixture is also called impure substance. Now, a mixture contains two or more pure substances. So a mixture contains two or more than two pure substances. What are pure substances? Last time only when I was teaching you elements before, means initial stage of this chapter, I taught you pure substance. So what are pure substances? Substances made of same kind of particles, elements and compounds. And substances which are made of different kind of particles, mixed in any ratio are mixtures. So mixtures contains two or more pure substances, that is elements and compounds. Elements and compounds. So how they are combined? Combined in any proportion. So you may be saying, okay, compound also contains two or more pure substances. So then what is the difference? So what is the difference? In compounds, it is combined in a fixed proportion, in definite proportion. But mixtures combine in any proportion. For example, the air we breathe is a mixture of many gases. So the air that we are breathing is a mixture of many gases. And what are the gases present in air that we breathe? Is nitrogen, oxygen, carbon dioxide, water vapors, etc. In this etc. you can say carbon dioxide, water vapor is there, then some of these noble gases are also present. So in a mixture, the original properties of the constituent components are retained. So in a mixture, components means those substances which combine together to form mixture. So components, the properties of the constituent components are retained. They will not lose their property. For example, I will tell you. Salt, table salt. So what is the taste of table salt? Salty. Then taste of water, tasteless. When you mix these two and make solution, then what happens? Then this salty water is salty to taste. That means salt has not lost its property. It was salty, and in the mixture also it is salty. So it has not lost its property. Okay, it has not lost its property. Okay. So these components can be okay. So that means, so what is another point, important point to remember in a mixture? The original properties of the constituent components are retained. Also, these components can be separated by simple physical means. Just before this, I said you compounds can be broken down into simpler substance, but by which means? By chemical means. But components of mixtures can be separated by simple physical means. For example, salty water containing salt. So can we get the salt dissolved in water back? Yes, by the simple process called evaporation. So by the simple process called evaporation, when we start heating this mixture, until and unless all water evaporates, we will get the salt back. That means components can be separated by simple physical means. The concentration of the components of the mixture can be different. For example, I can make salt solution by adding 1 spoon of salt also to a glass of water, or by adding 2 spoon of salt in 1 glass of water. So, for example, combination of sand and salt. Combination of sand and salt. If you mix sand and salt, it is a mixture. Sugar and salt, milk, honey, cough syrup and water form mixtures. So these are all mixtures. Okay, then let's see this one. Aim. What is the aim of this activity? To demonstrate that properties of compounds are different from those of the mixtures. So properties of compounds are different from those of the mixtures. Materials require sulfur, iron fillings, porcelain dish, bar magnet, watch glass. Procedure: take some iron fillings and sulfur, and so here this sulfur, yellow color solid substance, iron fillings, iron powder, you can say iron powder. So when you mix these two, then you will get a mixture. When you add physically, when you mix these two, then you will get a mixture of iron and sulfur. Mixture of iron and sulfur. Now to this mixture, if you bring a bar magnet nearby, you can see that iron fillings will get attracted towards the magnet, and in this porcelain dish you will get sulfur only. So what will be left? Sulfur only. What will be left? Sulfur only. You will get sulfur only. That means iron can be easily separated from iron sulfur mixture. Okay? That means iron, if you bring magnet here, iron will get attracted. And if you bring magnet here in this mixture, then also iron will get attracted. That means iron has not lost its property. Iron has retained its property. Iron has retained its property. So in mixture, components retains their properties. Okay, so here that means this is a mixture. And again, if you take this mixture and in a porcelain dish, if you start heating this, then it will melt. Iron and sulfur both will melt, and different thing will be formed, that is compound. That is compound. What is formed here in B? In A it is a mixture, in B it is a compound. So what happens now after melting all this, after fusing, you keep it for a while and then bring magnet. Then what will happen? You will see that iron will not get attracted towards the magnet. You cannot see which one is iron and which one is sulfur. So if you bring magnet here, nothing will get attracted toward magnet. That means iron has lost its property. So in compound, components will lose their property. In mixture, components will not lose their property. So magnet attracts iron fillings from the mixture of iron filling and sulfur powder. Then observation, the iron fillings are separated from the powdered sulfur. Iron fillings are separated from the powdered sulfur. A black colored substance is formed in the porcelain dish. Inference, that means conclusion. The magnet attracts iron fillings towards it, thus separating them from sulfur. A new substance is formed by the reaction of iron and sulfur when they are heated. When they are simply mixed, they will not lose their property. They form mixture. But when they are heated, they form new substance. That means heating. Here heating has made a new substance. The new black colored substance formed is iron sulfide. So what is the new substance formed? Iron sulfide, a compound of iron and sulfur. The properties of iron sulfide are entirely different from the properties of both iron and sulfur. This reaction can be represented as follows. Iron Fe plus sulfur S. So what is the color of iron? Dark gray. Sulfur yellow. Then the product you are getting is iron sulfide, which will not get attracted towards magnet. And the color of this is black. And you can see molecular composition has changed. It is FeS. FeS. Now, On the other hand, the mixture of iron and sulfur has all the properties of its both the components. Mixture will have properties of iron as well as sulfur. The components of this mixture can be separated by applying suitable methods based on their properties. So these can be separated from the mixture, sulfur and iron can be separated. But from B, that is compound iron sulfide, nothing is separated. You cannot separate it by physical means. Then, what are the characteristics of mixture? We have seen the activity, so now we must be able to say the characteristics of a mixture. So let's see. Number one, in a mixture, the components can be mixed in any proportion by weight. We can add any amount of components and then we can get a mixture. But in compound there is a fixed proportion. In compound there is a fixed proportion. In mixture we can add any proportion, any amount we can do. Hence the mixture is not homogeneous. Hence the mixture is not homogeneous. Mixtures are not homogeneous. The individual components of a mixture retain their original properties. That means mixture can be homogeneous as well as heterogeneous. Mixtures can be homogeneous as well as heterogeneous. Mixtures can be homogeneous as well as heterogeneous, but compounds are always homogeneous. And the individual components of a mixture retain their original properties. And in the mixture, component will never lose their property. If you make sugar water, then sugar is sweet to taste, sugar water is also sweet to taste. Means sugar has not lost its property. Okay, this much for today. Hope you will be doing the work that is associated with this video. Thank you.